G'day everyone and welcome to week 4, which is about Panarchy and scale. I've chosen to look at Panarchy and scale through the lens of the Daintree rainforest in Queensland, Australia. Throughout this presentation we'll be looking at several complex adaptive systems within the rainforest itself to help us get a better understanding of what Panarchy is. As a quick bit of context for the Daintree rainforest, it's situated in Queensland, Australia, and it stands as one of the oldest and most biodiverse rainforests on Earth. It covers around 1,200 square kilometres, and it's a UNESCO World Heritage Site cherished for its ancient landscapes, its massive biodiversity and its cultural significance. Panarchy is a conceptual framework used to understand complex systems, particularly in the fields of ecology, economics and social sciences. It was coined by the ecologist C.S. Holling, and Panarchy emphasises the interconnectedness, dynamics and adaptive nature of systems across different scales of organisation. The Panarchy concept is characterised by nested, complex adaptive cycles in which smaller scaled systems sit within larger scale systems. These nested systems can in turn influence one another through cross-scale interactions known as remember and revolt. It is also important to note that the concept of a Panarchy emphasises the importance of both resilience and transformation within a system. As stated above, the Daintree rainforest is large and extremely biodiverse. It has been cited that within a single hectare, roughly 120 to 150 different species of tree can be identified, along with countless species of mammals, birds and invertebrates. Whilst this conceptual 1 hectare stand of rainforest trees is the smallest scale I will explore in this presentation, it within itself is a very large scale complex adaptive system comprised of the cycles taking place on the most minute of scales, which again represent even smaller complex adaptive cycles. Within the stand of trees, processes including nutrient cycling, the spreading of seeds, destruction and creation of habitat, soil conditions and light availability all combine to form the 4 phases of a complex adaptive system. On a larger scale, the landscape that the many stands of trees are a part of act as a complex adaptive system as well. Influenced by both larger and smaller scale systems, our theoretical middle level system, a landscape, is the recipient of the results of both revolts and remember mechanisms. When examining the Daintree rainforest at a landscape scale, the factors affecting the system can vary widely. Some of the main factors that affect the Daintree rainforest at a landscape scale include flooding, drought, soil quality, and agricultural and urban expansion. Urban expansion, as well as agricultural expansion, has driven the building of many kilometres of road within the Daintree region, particularly in areas outside of the national park. The 1980s in particular saw the subdivision of land and the building of roads in the Daintree lowland rainforest, which meant the separation of the coast at Cape Tribulation from the Daintree rainforest surrounding the Daintree River. Societal development and the multitude of mostly negative factors associated with it drive increased disruption in the Daintree and test the resilience of the broader system. The conglomeration of these landscape systems and their associated cycles form again a larger scale within the Panarchy we've been discussing. In this case, the larger scale system is defined as the Queensland Tropical Rainforest ecoregion, which includes the Daintree rainforest. At this scale, the factors affecting the system can be viewed at an even larger scale, including world climate variation and climate change, continental biodiversity values, broad cultural views. Despite much of the ecoregion being protected by national parks and biodiversity legislation, threats such as deforestation and climate change continue to seriously contribute to destabilisation within the system. Interconnection and cross-scale dynamics are vital to understand when discussing the concept of a panarchy. The concept of remember refers to a system's ability to retain a memory from larger scale cycles. Revolt refers to a drastic or rapid transformation within a smaller scale that influences cycles within larger scale systems. To get a better understanding of how the dynamics of remember and revolt work as cross-scale dynamics, I will use ecological succession in the Daintree rainforest. Ecological succession can occur over many different scales. However, the most useful example I could think of would be a large number of tree falls within a short amount of time in an established tree stand. During this disturbance, the stand draws upon ecological memories from smaller scales in the form of regrowth and restructuring of the canopy layers. This disturbance period may also allow for revolt. This may come about as an increased prevalence of invasive weeds, which could impact the biodiversity values of not only the scale of a tree stand, but also at larger scales, eventually decreasing the biodiversity value of the rainforest itself. It is also important to use the concept of a panarchy as a lens to view ecological resilience and transformation. Using our previous example of a tree fall to explain interscale dynamics, you can see how the different scales interact to provide resilience and sometimes transformation. However, the more complex a system is, the more failure points are present. It is, though, however, true that adaptive systems, when existing within a panarchy, can also draw upon ecological memories or be changed by revolution to counteract and mitigate complete failure. However, when disturbance factors become overwhelming, such as beginning to be the case with climate change, these mechanisms are tested to breaking point, and in some cases, many systems, large and small scale, will fail. Thanks everyone. I hope this presentation has given you an insight into how panarchies function. I look forward to this week's discussion and everyone else's view on this interesting topic.